Hey there, spacers. Welcome to the Space Revolution. My name is Rick Tumlinson. You are listening to iRock Space Radio. We're part of the iHeart Radio network. Today, I'm excited. I one of my old great best friends on, and I've had a couple of them before here, and as you know, that means anything is possible. Um, so, Grant Bonin is one of those rare Canadians that I like. No, I'm kidding. He's we go back and forth all the time on this, but Grant is from Canada. Grant is one of the world's top, without a question, one of the world's top satellite designer, engineers, team leaders. Over 100 satellites, not the ones that you get mad about today. I'm talking about working satellites that are up there. And he's helped build, design, or fly those. So Captain Satellite, is with us today. We're going to talk a little bit about some of that. We may actually, you know what, Grant, we will talk a little bit about the orbital debris issue. But Grant's background, he was born in a log cabin in the woods of Canada. No, actually, um, Grant went to Carleton. Can't help myself, man. Went to Carleton University. He has a bachelor's in engineering, aerospace, mechanical. Got a master's degree in aerospace science and engineering, University of Toronto. He was at the University of Toronto SFL, is what it's called, Space Flight Laboratory, and did a bunch of satellites and spacecraft there. He was with our legendary Deep Space Industries asteroid team. He was our chief tech officer, chief engineer, guy who knew about machines. And when we were trying to reach out into the solar system and do asteroid mining, Deep Space Industries, so much fun. Uh, after that, after he recovered, he became the chief engineer at Rocket Lab. You've heard of them. I've talked about them before. One of my favorite companies. Chief engineer of space systems. Um, then he became a senior VP of business development at Spaceflight, which was the integration service that worked with a lot of companies, including SpaceX. And after that, and currently, his company is called Gravity Lab. Um, we're going to discover Gravity Lab together because we haven't talked a lot about it, Grant and I, um, but I'm sure it's exciting. So, welcome aboard, Grant.
Well, thanks, Rick, and thanks for having me join the revolution in maximum audio and video format.
There you go. Always for you, my friend, just for you. Usually it's minimum audio and video format, but for you, we're going max, man, all the way. So Grant, tell us about Gravity Lab. What do you guys do?
Right. So, as you've come to expect from knowing me, Rick, there's a short story and a long story to it. But the short story is that um, usually when we talk about people living and working in space, which is the thing that you and I love to talk about, um, there are two problems baked into that. How do you get there, and how do you stay there? And the lion's share of thought amongst our friends over decades has been about how do you get there, but not so much about how do you stay there. And if we're talking about millions of people living and working in space, what we're talking about is quality of life. What we're talking about is settlement. And baked into all of that is that we need to be able to have babies. So that's where the problem pops up. You and I know that one Earth gravity, what you and I are feeling right now, is good. We know as a community from decades of human spaceflight that zero gravity, what they experience on the International Space Station, is bad. But we have no idea what it looks like in between. But all the destinations we talk about living and working in space um, are in that in between zone. So The question is really, is there a gravity limit or a gravity threshold where life struggles to thrive or even survive? And if there is a gravity threshold below which we can't grow Matt Damon's potato on Mars or have a baby, if these thresholding effects exist, then we should find out, and we shouldn't find out the hard way. But right now, there's just no easy way to do it. Everybody is talking about doing it the hard way. So let's dodge that. Gravity Lab is a company that exists to figure out what the gravity prescription is for life in space that endures. And um, as a commercial company, the long term goal is to create the gravity pill, which is an oversimplification, but create the gravity pill that helps us adapt better to the spaceflight environment. Um, the nifty thing that makes us investable along the way is that the kind of spacecraft that we would construct to investigate this problem also become these incredible platforms for manufacturing new materials that people haven't really thought about doing before. Because again, we're used to thinking of gravity as binary, 0 or 1G. But if I can give you the experience of anything in between for as long as you want it, um, that helps you rethink the problem quite a bit. So that's like the 3 cup of coffee overview of Gravity Lab. It's a venture-backed company that myself and a gentleman named Chris Lewicki co-founded about a year ago. Chris had been the lead flight director for Mars Spirit and Opportunity, and also the CEO of our principal competitor, Rick, when you and I worked together at Deep Space Industries.
Yeah, so I want to. I'm going to. This is fascinating. We're going to have a lot of fun talking about this. I do want to point out to the audience that Grant is the master of metaphor. He doesn't really mean that you're specifically going to take a pill, although it may mean that you take a pill. What you're really saying there is a solution that allows people to have these activities. Correct?
No, you're spot on. You're spot on.
Okay, good. Because I know somebody was like, "Oh, I'm going to order that," and we'll put the little thing up at the end, and you can order the pill.
Well,
So,
if I could order it, I would. But yeah, at its root, the question is, um, hey, is there a cutoff point? If
mhm,
like 50% of the gravity that
right.
you feel right now is the cutoff point, you go below that and things get bad, then it means that we're pushed towards a more, I guess, O'Neillian type future where free space colonies are the going to be the right answer for life's adaptation. If we find that threshold to be about a third of what you feel gravitationally right now, then Mars is on the table, but the moon isn't. And so there are no mundane answers to this question. But the value that you want to pull out of humans living and working in space is going to be blocked by the answer. So let's, again, figure it out now.
Yeah. So, just for the audience again, the O'Neillian concept is rotating habitats that provide at their on their outer walls, let's say, or the floor, which is rotating, one gravity or the simulation of one gravity. And Dr. O'Neill's point with that was that if it turns out that one or multiple generations in, living on the moon, which is 1/6 of our gravity, or on Mars, which is 1/3 of our gravity, um, you might adapt so much that you couldn't come back and forth, let's say, to the Earth. So, a slightly different question than can you have babies? But his thought was if we could rotate these big habitats and have 1G, one gravity, that it would be much more simple for people to come back and forth to the Earth. Correct?
Yeah, spot on. And Mars is a little bit more than 1/3 of an Earth gravity that you're
Mm-hmm.
experiencing right now. It's 0.38 Earth gravity. So multiply 1 by 0.38. That's the fraction. On the moon, it's 0.167 or so. And the question is, and we've been spending a lot of time doing life sciences experiments on the International Space Station, and
Mm-hmm.
we've learned a lot. but we haven't tackled this problem head on. And we have anecdotal evidence, even at this with simple, very simple plants. We have anecdotal evidence that there are gravity threshold effects that influence growth, but we haven't figured that out. We haven't figured out fire suppression and how it works with gravity. So, let alone whether or not mice can have babies as potential model organism examples. And so this is a huge field that hasn't been tested, but it does stand between where we are now and a vibrant off-world economy that is, about humans, which I think Rick, you and I, and the number of the people who'll be listening are gonna want to see happen. And so there's just these thundering uncertainties that people are not exploring. And so we wanted to get out there and create a company that could explore answering these questions, but in a really cost effective way. And when I say that, what I mean is, my background, as Rick alluded to, is principally in small, low cost spacecraft. So I started saying to myself almost 20 years ago, actually, um, hey, what's the lowest cost way I could create a gravity lab, as it were, to experiment with? Hey, can mice have babies in these fractional gravity environments? Can we build things in these fractional gravity environments? And the same principle that Rick mentioned when describing the O'Neillian concept is what we're talking about here. If you take a bucket of water and you swing it over your head on a rope, you're not going to lose a drop of it because of central force. And same principle with spacecraft. But if you vary how quickly you spin them, you can emulate gravity. And if you decide to commit to doing that for a long duration, then you can offer customers a long duration gravity experience. Um, so it's not very difficult to imagine that starting quite small in spacecraft that are like the size of a refrigerator or a washing machine. But that same effect of spinning to create gravity scales very, very well to small space stations. And then all of a sudden, I'm already in the future that I care about. So that would be success. But there's a straight line that you can point or that you can draw between these very small platforms and things that are human tended or human occupied. But I assume we'll get more into that as we discuss the concept a little bit more.
Yeah, and what's interesting is, I've been a political policy creature off and on, and during my career in this, and I was always frustrated that we were being told, the space station was going to be a place where we'd learn how to live in space, and as doing some of the early iterations of the International Space Station, the centrifuge was tossed out the airlock. It was jettisoned as part of the plan. Um, and 2 points with that. One, it took me a long time to actually realize why that it was so easily jettisoned. And two, the fact that it has been jettisoned has actually now become a business opportunity for you. So in a way, I'm glad they did. But here's the thing for the audience. This is Rick's theory of government space exploration, and that is that the mandate to NASA has never really been to put together the building blocks that would allow human beings, American citizens or citizens of the world, to be able to live and procreate multi-generationally in space. It's never been their mandate. We like to think it has. It's great PR. It helps keep the money flowing, but it's never been their job. Their job, as they see it when it comes to people, is to send them out on camping trips and then bring them back. So they've never really had to worry what happens, if they go out and they have babies and their babies have babies and their babies have babies or anything like that. That wasn't their mandate. It wasn't the job that was given to them by Congress or the parliaments and ESA and all of that. So until it is, that's not really going to be something they do. And going back to my second point, then Grant, and we're going to come back to this in the next section. Um, what Grant is doing, and his team, is filling that. I'm sorry, it's a pun. That vacuum, and coming in with a business that is going to do it. Why is a business viable right now? We're going to get into that in a minute. We're going to get into um, these different questions, these different variations. But right now, we're just going to take a spin out of here. We'll be right back. Hey there, Spacers. Welcome back. It's the Space Revolution. My name is Rick Tumlitz, and you are listening to iRock Space Radio. We're part of the iHeart Radio Network. Our guest today is Grant Bonin, satellite builder extraordinaire, one of the top satellite builders in the world, who has chosen as his task, as part of opening up the high frontier to humanity, taking on the question of gravity. How much do we need, and how do we build the facilities to understand it, create it, and eventually build it out there? So we had come to this point where we're talking about the fact the government never did it. You guys have a business opportunity. Who's your customer for this, Grant?
Right. So it's a great question. So the joke that I used to make when I was doing spacecraft business development was that you want the tripod of customers. You want your commercial customers, you want your civil space customers, you want your defense customers, and so a balanced approach, I would argue, goes after all three. And so for us, some of the early NASA customers that or end users with whom we're engaging are interested in the physical sciences. So things like fire suppression research. You wouldn't think of this as a problem, but when you're designing a lunar habitat, the exact conditions that you create from the standpoint of atmosphere plus lunar gravity actually make it very, very easy to start fires and very hard to put them out.
Mm-hmm.
So there are physical sciences questions that are extremely relevant to Artemis that we can tackle on the civil side. On the defense side, it's a little bit counterintuitive, but with big platforms that we're trying to create that rotate end over end, there is opportunity for non-traditional signal intelligence, where as you're rotating end over end, you can look at the time and frequency difference of signals that come off the Earth and can be detected by your spacecraft. And that means you can geolocate them. That's very exciting from from the standpoint of supporting the United States and its intelligence gathering activities that are typically done from space in a non-traditional way. Thirdly, and probably most interestingly, is to me anyway, because I'm a commercial guy, is what comes out of the commercial marketplace. And it's really twofold. There's the pharmaceutical and pharmacological research that stands to enable human settlement of space. It's the most speculative, but it's the biggest opportunity. And I don't think I have to convince Rick that the expanding our economy into space is going to be a good thing. It's best served by people, and so people living and working in space is the long term opportunity. But in the shorter term, if you can turn gravity on and off at will, and you can set it to any set point between zero gravity and one gravity, like you would set your thermostat in your house, then that opens up the opportunity to manufacture things that nobody's ever contemplated building before. And that can be as simple as removing, um, as using gravity, or as being able to program down into a fabrication process to finish building something, or it can be as complex as introducing different material properties into a thing that you are trying to build in space. There is a broad spectrum of just unthought of opportunities when you start to treat gravity as something you can control. And so that's where this goes from something that's speculative and maybe a little early in terms of human spaceflight to something that is pragmatic and addresses real markets right now.
That's fascinating. My mind, of course, is exploding and will continue to explode. So if you hear popping sounds, that's my brain exploding. Um, yeah, you're talking about variable gravities in the manufacturing process. So you could actually have some sort of material that one layer of it was done, and it could be all one contiguous, one solid piece of material. One
Yep.
layer would be annealed or completed, in the zero G. The next layer might be one third, the next layer, or one sixth, the next layer, one
High value.
third.
Yep, high value semiconductor lasagna. You
I
get a
like it.
layer. You get a layer that you made in microgravity. You get a layer that you might have made in something that is a tenth of a G. You get a layer that was made in 50% gravity, and then you finished it because you could move it with acceleration at one Earth gravity. Um, People aren't used to thinking about manufacturing this way. So this is
No,
the challenge as well as the opportunity of the business is socializing a very broad community to the utility of this kind of service. Um, but that all takes me to step one, which is getting the flight heritage and being able to point at something and say, this is real and it's happening and it's available to you for service right now. People don't think about gravity as a service right now, but
right.
if I have my druthers, that'll change.
Yeah, and it's interesting because one of the forefathers, shall we say, of all of this is a guy named G. Harry Stein. He wrote a book called The Third Industrial Revolution about space. And I remember I was young when I read it, younger when I read it. And the thing that stuck in my mind, he does this whole essay on how in World War II, a lot of money was spent bombing German ball bearing plants because ball bearings were so important. And then he says, but when we get into space, we can create perfect ball bearings. And then he goes to the next level and says, and we could do stuff like get titanium and lead and create a material that combines them both in a new alloy. Because normally in gravity they won't work together. And so you end up, and he explains that, these are getting, I don't want to go off into the weeds on this, but the lead is sort of self lubricating. It's kind of slick. It's got that feel to it, and you can put that with the titanium, and then you end up with like amazing ball bearings. And so what you're doing is, and that's just, let's call it micro G, zero G. That's just one level. You're going like the entire spectrum from there to the gravity of Earth, all the different possibilities that you could then create with these sorts of metals.
Yeah,
Go ahead.
you're spot on, Rick. And one of the things that we're intentionally careful about is, we don't want to eat anybody's lunch in any of these market verticals. We want to be a platform that enables people to play around with, again, gravity, programmable gravity, gravity as a service. I don't usually like the dot 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 as a service rhetoric, but you get the idea. And there are business models that we can wrap around that don't involve us cannibalizing our customers. So we see this as very much as a platform to vet whether or not there are opportunities in these otherwise not really thought of very often markets. And you make you use a good example. Another good example, though, is with increasing emphasis on uh, semiconductor manufacturing in the United States, for example, and
Mm,
some striking characteristics that can be introduced into semiconductor fab processes with partial gravity services. People don't think about it very often, but with increasing emphasis on the United States will be, manufacturing a significant amount of its semiconductor product output for the foreseeable future. Um, there are just a lot of opportunities that are emerging that are terrestrial, and this is a thing that I think you said when we were at Deep Space Industries that our customers don't have to care that our pursuits are really grandiose. They don't have to care that settlement is our goal to recognize that our pursuit of it can generate great products and great capabilities. And that's how we think about it at Gravity Lab. Is we're chasing this big dream. Our pursuit of it can generate great capabilities for we'll call them more down to earth companies right now.
mhm, mhm. No, and so in essence, your starting place, I guess, is, correct me if I'm wrong, but a packaged sort of centrifuge type of set of devices. Is that correct?
Yeah, and you're spot on. And it looks like there are multiple iterations in the roadmap, but at the end of the day, you can kind of picture it as a very long pendulum, or a chopstick, or a conductor's wand, but
Hmm.
something that is tumbling end over end that can generate that centripetal acceleration to emulate gravity, but in a controllable way. How we actually do that is we take a spacecraft that's about the size of your oven in your kitchen, and it uses a boom that's a lot like a tape measure, and it extends counterweight, so that you've got a nice pendulum. Once everything is extended, you use some control jets, some reaction control thrusters, to spin this system up to, again, generate that programmable, that artificial gravity. Um, and by varying that rotation rate, we can vary the gravity that is experienced inside of the spacecraft's cabin. And the cool thing about this is that it's our spin, pun intended, I guess, on this idea is really to use booms instead of tethers. So things that are closer to a tape measure than a wire, that helps things avoid getting tangled. To get into the weeds of it, I guess you can kind of imagine if you have a tape measure in your hand, you can extend it by some handful of feet before it buckles, but before it collapses on you. But if you hang it from the ceiling so that it's always under acceleration, you can have a cat swat at it all at once and it will stay taut. So a little bit of rigidity in these types of booms combined with keeping them continuously in tension, gives us a stability that you wouldn't have contemplated doing without building a much bigger structure. And so that's not magic. That's just some engineering.
Yeah.
And the controllability and dynamics of that's where the fun engineering actually happens. But overall, you kind of nailed it. There's a family of big spinning, rotating spacecraft up there that are big enough to be useful, much bigger than the centrifuges that have ever been flown on station, but small enough that you can do a mission from orbit to orbit in 2 years. And a
Hmm.
predicate of the company was that every single mission, at least in phase one of our roadmap, would be single digit millions, single digit years, and it should be as easy as possible for somebody to buy one from us. And I think we are realizing that. But
That is
the entrepreneurial road is long.
that is so unheard of. How dare you do something in single digit years, single digit numbers, and make it
Crazy.
cheaper? Oh my god. Yeah, and what's popping into my mind is sort of like it's somewhere between taking that bucket on a cord and swinging it, and that thing you see at every carnival with the two capsules on which I will never ride, that is on the end of the arms, right? It's
Yeah, my
uh,
stuff's not being put together by an 18-year-old working minimum wage.
yeah,
So I'm
a
always
carny.
excited about, should we call it innovation and labor? But at some point you decide that you're reassuringly expensive relative to other people's goods. Then,
Right,
but
right, but
yeah, no,
but
you're
the but
spot on.
yeah, and so the idea though is you've got that kind of rigidity. You've got these sort of capsule things at the end that are your test modules, your whatever you call them, which you should come up with a cool name and trademark it. And because you're using sort of this tape measure thing, which as tape measures go in and out, you can control the extension of that, which means you can control the Coriolis. I mean, yeah,
Oh no,
the
no, you're
spin.
right. You're spot on, and it's the other analogy that can be useful is like a figure skater, um,
Yeah.
that extends and then contracts their arms.
Hmm.
And so yeah, that I mean that is phase one of the roadmap. Phase two is where it gets interesting because phase two is about, all right, we have these labs that do long duration gravity experiments. Now we're going to bring them back. And we're not going to bring them back in discrete capsules. We're going to bring them back as entire spacecraft. And that means that we're entering the world of the refurbishable spacecraft. That is very exciting to me. It changes our unit economics. It really changes how we can price missions like this. We'll be doing it in partnership with others because there are parts of that problem that I am not a world expert in, and I don't intend to spend half my career figuring it out. But the ability to program gravity, combined with the ability to return and refly a spacecraft, the reusable spacecraft model that complements the reusable launch vehicle model, that's where things get really, really fascinating from my standpoint.
Okay,
Because
hold it. Hang on, hang on.
investors think of it too. Sorry, go ahead.
No, hang on. So you've got the little capsule at the end of the tape measure.
Yep.
It's a spacecraft.
Uh huh.
You're spinning around. You throw it off. It goes down.
It's a little bit more controlled than that, but you're exactly right. You're exactly right.
Right.
The,
So you would have to balance the momentum and blah, 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 all that with the other end of the. But the module itself leaves, goes back down to the Earth. Another one's coming up, let's say, and attaches at the end of that. And that's your another experiment. Is that the? Am I looking at this, or am I getting
no,
carried away?
so the counterweight and the boom get disposed of, or part of that subassembly gets disposed of. Part of it could be reused.
Okay.
But most of the oomph, most of the money is in the experiment volume and the bus, which is the support equipment that generates power and provides propulsion. And so I want to get it back. And even at a small scale spacecraft, that has a pretty significant impact on the unit economics of the business that we're wrapping around this. So phase one is show that we can generate artificial gravity and that we can program it. Phase two is be able to return these spacecraft and reuse them. That's pretty exciting. And phase three is about scaling. I'm painting like in super broad strokes, but that's kind of the overarching approach that the Gravity Lab is trying to tackle. But the reusable spacecraft model is just not something a lot of people are thinking about enough, in my personal humble opinion. And I would like to believe that I'm wrong. Um, so so there's a lot that there's a lot of fun that we're going to get to have if we have our druthers going downstream. And most of the high value work that we want to do requires returning samples anyway. So why do it with discrete capsules when you can reuse the entire spacecraft? And if we're not thinking about reuse either in flight or bringing things back to the ground, then I think we're doing it wrong in general in space. And I certainly feel that way about launch. I just think it should be extended to the space component.
So anybody who follows me on LinkedIn and Twitter X Twitter, whatever the heck Elon is calling it this week, knows that I am massively in favor of what I call the 4 R's: reuse, recycle, repurpose resources. So you're singing to my heart, man. So and everybody should be doing that. So it's great that you are doing that. So we're going to come back in a minute, and we're going to talk about who are you attaching to it first, possible first customers, and then the next level, which becomes the biological passengers of this thing. So we're going to come right back. And I know it's a heavy conversation because it's all about gravity. We'll be right back. All right, spacers. Welcome back. Um, you are listening to the Space Revolution. My name is Rick Tumlinson. You can follow me on X, Twitter X, whatever, at Rocket Rick. I also urge you, if you're into a little bit more depth, I post all the time on LinkedIn, which is turning out to be kind of where the spacers go to hang. Um, our guest is the amazing Grant Bonin. And by the way, I should mention we are iRock Space Radio, a part of the iHeartRadio network. But our guest is Grant Bonin. Grant, top satellite engineers on the planet, a a genius in his own right, maybe in his own world. No, actually one of the smartest guys I know, and we are talking about a heavy subject, as I was badly joking about artificial gravity in space. So, Grant, where we were was you've described this amazing reusable spacecraft at the end of a tape measure for rigidity type situation that you can extend in and out to variable gravities for different kinds of experiments. We have been talking about, different kind of materials you can make and circuit boards and circuits and, computer chips and ball bearings, all that kind of good stuff. So, first question is, um, are you going to be attaching to anything? Like, are you going to be, attaching it to orbital reef, maybe at the end or at the end of the Axiom space station, or one of these, and you'll be spinning up there. So, talk about those relationships if you can.
Yeah, sure. So the initial missions are intended to be completely um, unassociated with those emerging space stations. So I'll broadly describe these as members of CLD, which stands for Commercial LEO Destinations. This is the NASA program to replace the International Space Station, and there are a number of like really great and very different offerings that are being made in that space. And then there are other people who want to build space stations that are not participants in that program yet, but are also fielding some really, really great space station concepts. But we're not associated with any space station, and there's a specific reason for that. Um, 80% of so we let me take a step back. Excuse me. We spent about the first 4 or 5 months of the company doing customer and market discovery to figure out, um, do customers actually do people actually want what we're offering? Because they're Rick, you've seen this before, and you've seen it from me. There are a lot of engineers out there with a solution looking for a problem. So we
Yeah.
wanted to make sure that we were actually onto something.
Hmm.
But we discovered two things: one, that yes, there's a lot of work to be done, but two, you don't really want a lot of this research done in a human occupied or human tended facility for the same reason that you probably don't want to go eat dinner in a biohazard level 3 facility. And you sure as hell don't want to, you'd rather stay at a Holiday Inn Express than a CDC location overnight or an ER. The work that wants to be done to knock out the risks associated with partial gravity is often uh, wholly incompatible with human hands. It can
Hmm.
benefit from human hands interjecting periodically. But if you want to do an offering that is space tourism related, and you also want to do some of this manufacturing work or some of this multi generational life research that we want to do, these are oil and water. They don't mix very well. So we see ourselves as very complementary to the emerging new space stations. The design of the spacecraft, and go to our website or contact me if you want to geek out about that. um, but it's intended to be a Lego building block approach that can result in a station adjacent or a station docked despun facility, despun with respect to a space station but rotating in its own right. It's almost like a mudroom for the station to do these kind of experiments. And yeah, the whole idea is this is complementary to a lot of the work that the zero G stations are going to do, specifically because they're not doing artificial gravity, but also to the stations that want to spin themselves up to generate gravity as part of the user experience.
Hmm.
Those users and that market is ostensibly tourism, and they sure don't want to get their hands dirty with fire suppression or with rodent research. So they're very complementary offerings from our standpoint, and and so we try to stay friends with all the space station people, but we're following our own road. If that's a long-winded way of answering your question. Hopefully, I got at least half of the way there.
No, and I can see it. Like if you were doing, like you're trying to produce these super pure wafers and stuff like that, and you're attached to a station and somebody's docking off and on, you're going to get like resonant vibrations shooting down the thing. It's not going to be a pure experience
Yep.
for the formation of what you're trying to do. Um,
And if you need hard vacuum, if you want
yeah, so I get it. I get it. So, but but
control.
in the end, when you cross over to those fleshy beings who we try not to use the T word here, but fleshy human beings, citizen space explorers, whatever they are, private astronauts, guests, as they are usually called here on Earth, um, providing, it's almost like you're going to start with this industrial approach, but you're going to be pioneering where they're going in terms of their ability to spin things. You're going to be like
Well,
the experts of spin.
we're trying to knock out their risks without them having to get their hands dirty.
Exactly. Exactly. So you'll be the experts. You'll and then they're going to intersect with you at some point when they can actually start spinning things.
Well, that's the opportunity, and it's actually it's really interesting in the current investment climate
Hmm.
because institutional venture capital and space have a very interesting relationship. It's its own podcast that you would be an expert in hosting or narrating. The tricky thing here is that the there's a bread and butter business associated with the physical sciences and manufacturing. So of
Hmm.
course we're going to go after that. The venture capital compatible part of the business is ostensibly about people living and working in space, but it's a little bit more speculative. Um, this is why we're not diving into any of these areas ourselves. We haven't done our own dive into manufacturing or into crystal growth, for example. Like we want to be a platform or a service that lets people play around with this stuff, and there are business models that are pretty fun that are thumbs up from our standpoint. But the 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 true utility of discovery is very hard to know historically. It starts with a what's that? And if you map this to an investor or an economics discussion, this is a blue ocean strategy. We are competing against non-consumption. We're going to a place that nobody else is, declaring that we're going to generate some value by doing so, and looking for people who are willing to make that crazy bet. Um, and I would be dishonest if I said there's unambiguously a venture scale market associated with what we're doing here. But if you do believe rather that there's going to be a human future in space, that our economy in space is going to be human driven, then there is a market for this. If you don't believe in those things, then we're unlikely to be interesting to you if you're an investor or even just a space interested person. But this is about a human future in space and trying to de risk the number one thing that for some reason we haven't touched in decades of human spaceflight.
Right. Right. And going back to the fact that NASA, that wasn't their job. It is our job. And frankly, anybody who's planning on doing large scale human habitation, be it on the moon or Mars or free space, needs to know what happens 2, 3, 6, 8 generations in. I have a thing I call it, speciation. I call it Homo marzialis, Homo lunaris, Homo spacialis. Right?
Mhm.
We need to know what that's going to look like. You will be probably at the leading edge of building the facilities that help us, um, and maybe you can hire that carnival guy to be the guy who cleans out the rodent experiment. That's the one that's always troubled me. Um, but
And we recognize and we're
yeah.
very excited by other fellow travelers in this, our friends at Gravitics, our friends at Vast,
Hmm.
um, other companies that are taking more of a space station centric approach to um, gravity as a thing that we should be creating ourselves, not necessarily hoping to find. um, and they're all pursuing this problem in very different ways. I'd say that Gravity Lab is trying to understand it and use it for manufacturing. Some of these other companies are trying to offer it as the comfort aspect of a tourism based market. I see these as completely complementary, and they both excite me. I'm just
Hmm.
cheap, and I'm used to building small stuff, so I'm going to keep building small stuff.
Yeah, and again, you're going to be able to work in once they commit at the scale they're talking about. You know, rotating hotel rooms or whatever it is they're going to be doing. Um, they're committed, and the infrastructure and everything that goes with that. You know, they're going to be like, this is what we're doing. Da-da. By the way, it's a hard problem. It's not that you just spin these things, right? Anybody who's ever spun a top, right? They start moving around. If you change, you know, if you have 30 people on one side and nobody on the other, you have to account for that. Yeah.
Yeah, so you just threatened to unlock the engineer in me, and you know that 4 hours can pass. But succinctly, yeah. So if you're, we want to do all of this in low Earth orbit, and that's where the lion's share of small spacecraft go today.
Hmm.
In low Earth orbit, you have a lot of so imagine you're spinning in exactly the way that you want. Well, you got to do a lot of housekeeping because you've got things that seem benign, like atmospheric drag or geomagnetic interactions or solar radiation pressure, that will disturb the spacecraft and make it want to wobble, is the easiest way to describe it. And that has to be actively managed. And that has not been done before. So the controllability and know how that we're going to learn about doing artificial gravity, to me, that is all by itself going to move the needle. Uh, if I have my druthers by the end of 2025, if not better, if not sooner, we'll have done the first large scale programmable gravity demonstration. And we will be able to inform the activities of everybody else that wants to do artificial gravity, that this is how you do it in low Earth orbit. And there is also a reason that we've designed our spacecraft to be compatible with commercial rideshare that isn't just low Earth orbit, because we want to go beyond low Earth orbit and also look at radiation effects. Um, there's a bigger roadmap than we're going to be able to get into in the context of this podcast, but I would encourage people to come to our website, which we will try to update with that because oh, it's just I am trying to contain my excitement and not talk for 5 hours. Um, but 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 there's
But we could.
but
Yeah.
just figuring out how to crack this nut is
Yeah.
going to be hopefully something that's important.
Well, I think, and we can wrap up the section with this. The point here is we get sometimes very simplistic um, imagery of these kinds of things, the rotating space station, you know, and some of us would be like outraged because, you know, the space station isn't rotating, you know, with the feet out or something, you know, because it's Star Trek and they have gravity floors or something. But, and then we're satisfied with that. But if you think about it in detail, and this is where, I mean, you're going to be rolling out patents and all kinds of good stuff on this. But this is also maybe where supercomputing and AI plays in because something, when you're rotating a large facility, let's say you've got 100 people on it, and all the fluids that are going through the sewage system and the water system and the people moving and all the mass in that entire thing that's rotating is going to be constantly changing, which will be constantly changing how that thing is rotating. It's going to be have to be there'll have to be like a compensation system or something, right?
Well,
And go
yeah.
ahead, we'll wrap it up on this.
Oh no, no. I was actually thinking of this is going to be a deep cut, but for the true nerds listening in, fellow nerds,
Mm-hmm.
in Star Trek: The Next Generation,
Mm-hmm.
the Enterprise D has something called cetacean operations. They've actually got a family of dolphins, apparently, that live on the ship and contribute to guidance, navigation, and control compute. And if you need a citation, we can put it in the podcast notes. But Rick, you're spot on. And actually, even with mission number one that we're intending to launch, there is a payload on board that is going to actively be shifting the center of mass around to watch what the disturbance environment looks like and make sure that we can control it out with the algorithms we've developed to maintain the integrity of the spin gravity approach. Yeah, it is not simple. And you are dealing with a really, really weird intersection of what is comfortable for model organisms and eventually humans with what can be effectively engineered. And it's a pain in the butt, especially when you remember that mass is the currency of rocketry, that fuel propellant is the currency of rocketry. You can take a lot of these errors out if we're willing to be reckless with a fuel budget, but not if you want
Mhm.
to save propellant and you want to be able to deorbit at the end of life, which we already discussed is something we would want to do. So it's a hard problem.
So the highlight of the last 3 minutes was being able to point out that along with one of the biggest satellite experts in the world, Grant is also the biggest science fiction nerd that I have
Oh,
known who does not daily wear a Star Trek
certainly.
uniform.
Oh, so well, I'm wearing Toronto Blue Jays uniform right now, so represent. But Rick, I think, was one of the few people who noticed my Sequest T-shirt once upon a time. But let's make that a future podcast.
That is an entire podcast unto itself. All right, spacers, we're going to be back for the last segment here. We've obviously barely scratched the surface. We're going to have to talk to Grant again. Maybe just on a pick out a topic and bring him back, and we'll just eat that one. All right, spacers, this is it. We are coming in. We're going in, going out, whatever. Last segment. We were supposed to talk about a bunch of other stuff, but we're just having too much fun getting in all the dynamics and all this stuff. And
I
look,
guess you'll just have to invite me back then.
I will. I will. After a long enough period for this to sink in, everybody to go out and get a PhD so they can understand what the heck you're talking about. But seriously, I think part of the point you're making here is coming through is that this stuff is not as easy as it looks. Um, it is not something that has had enough research done on it. And just very briefly, because I want to get into some other topics here real quick, but it is critical that if we're going to send people out to be um, permanent citizens of the moon or Mars, that we understand what happens for generation two, three, four, five, six, because we don't know, do we?
No, we don't, and I think it is essential. And the joke that I made at the beginning of the podcast was that um, there's the how do you get there problem, there's the how do you stay there problem. We're preoccupied, and by we I mean both. I think the interested population as well as aerospace engineers. We love our rockets, right? And we love our spaceships. But if we are talking about settling new worlds, and by the way, I'll echo comments that Rick has made before, settlement is the goal that ensures all other goals, right?
Mhm.
If you talk about exploration, it doesn't guarantee settlement, but settlement guarantees exploration. So let's talk about the thing we're really talking about. And for me, it is people, it is becoming a multiplanetary civilization. It's people living off world. We have to know the answers to these questions to pick the worlds where we can live. And I don't think a negative result or the problems that we might identify at Gravity Lab are deal breakers for the moon or Mars. They're just informing where we might want to throw our efforts. Um, the thing that's unacceptable to me is that we try and fail to settle a world, especially in a civilization that is decreasingly risk averse, or sorry, increasingly risk averse,
Yeah.
in a civilization where pretty much every one of your failures, if you do something ambitious, is going to end up being broadcast worldwide. Um, it is terrifying to me to try and fail at a Mars settlement that is multi generational. I
Mhm.
really, really want to not find out the hard way if I can raise my family on Mars. And that's again, that's just baked into the genesis of the company. That's why we're doing what we're doing. Um, And I don't mean that to sound pessimistic about our prospects. I just want to understand them. I'm a data driven guy. I'm an engineer by background, so I want the information. I want the knowledge. Now it'll never be perfect, but we're sure as hell going to know a lot more if we start flying partial gravity missions than if we fly zero partial gravity missions before we try to mount a human expedition to Mars. So that's our raison d'être. That's why we're here.
It's funny too. I think we might have both been there at the International Astronomical Conference where Elon first showed his video vision of the film of uh, Starship.
Yeah, it was in
And
Guadalajara, right?
yeah, Guadalajara, exactly. And the thing that struck me, and we need to keep this in mind because this is your market. This is the opening for everybody else to be involved who can be involved. Is that video ended when the airlock opened on Mars and the passengers looked out. It ended there. He was not selling how he was going to build that community. He was not selling anything beyond that. Basically, he's like, I'm going to give you the ride, right?
How do you get there?
That is it.
But how do you get there? But also, how do you stay there?
Yeah.
Oh,
And that's the second part.
and importantly, who pays for it?
Yeah. That's a whole, we'll go there a different time.
Yeah, that our economic future in space is about people in space, and that it's a real estate play is well, never mind. That's a topic for a different
No,
podcast.
no. Reality is what we deal with on this show. We don't deal with science fiction other than for fun, and we'll come back to that in a couple of minutes.
Yes, sir.
But seriously, since we're on that, and we're kind of going out here, let's just keep going out on this. We could end up with these different species of human subspecies of human beings living out there. I don't see that as a problem. Um, we
That's
could end up with a yeah.
diversity.
Go ahead, take that, go with it.
Oh no, sorry. I think I talked over you there, but at its core, diversity is just good.
Yeah.
It will be it'll be a really exciting, if maybe a little bit of a bittersweet day when there are variants or offshoots of human beings that can't easily return home. But
Mhm.
let's know, right? Let's not be reckless with the bodies of the people that will be that will represent our expansion into the universe.
Right,
Let's make sure they know what they're getting into.
right. I mean, there's two levels there. One is like, okay, so um, you can have, let's say we find out, okay, we can breed on the moon, we can have multi generation. Um, okay, they're probably, I have no idea. I am not a doctor. I just live on the same planet as some. But they're going to be probably taller. We may genetically breed in sort of some radiation tolerance. They're going to probably be comfortable in enclosed spaces, and a few other things like that. Um, and that's all fine, right? That's just fine. The people on Mars also maybe a little bit taller. They'll be able to deal with what is that chemical that's all over the surface that nobody talks about um, in the regolith? But there's
Well, you've got a lot of reactive species in regular.
right, right, and people on the moon will be able to easily cough lunar regoliths out. We had Phil Metzger on the show, and we did a whole thing about
Oh
what
yeah,
we call
Phil is Doctor Dust.
yeah, razor blade talcum powder.
Call him that, you can attract the wrong clients to him. So
Yeah, that's the wrong kind of dust. But no, I refer to it as razor blade talcum powder, right? And it's the big killer nobody's talking about, right?
yeah,
And the,
good luck. Good luck with joints on a spacesuit. By the way, you want to
yeah,
play around with that in a lunar gravity environment. You can try.
ah, hang on, that's a market,
Yeah.
right?
Okay. That's the physical sciences stuff that we think will be the low hanging fruit. Actually, I'm very confident will be the low hanging fruit for initial missions.
So you could take like the Axiom Space moon suit, take the elbow joints, fly them in a lunar simulating rotating Gravity Lab facility and learn a lot.
Yeah, we are in conversations with a couple of customers who have different variants of how they would like to do an experiment that way. But yeah, don't learn the hard way about the moon and Mars. Should become my new tag phrase because it's what I say a lot. But
Mm-hmm.
you're spot on that I think in the long term, no destination is precluded. It's just about making sure that we understand what the adaptations are going to be and understand as many of them as possible before going. Now, that's an
Right.
extreme value problem. If we learn nothing, we're in for a bad time. If we insist on having immaculate knowledge before we try to go, then we're never going to go. So the risk position needs to be intentional. But let's start having that conversation.
Yeah,
Uh,
it's somewhere. Go ahead. Yeah.
no, that's
Yeah. So it's somewhere between sitting on the couch and here, hold my beer. You know,
yeah.
watch this. But so look, I want to ask you two or three questions, then we're going to come back in. Uh, these are kind of traditional questions I like to ask people just to have some fun. So you're flying in space, and in your particular case, you're approaching an asteroid, and you're flying at several thousand clicks and in speed, and you are so you're very aware of the speed. What would you be listening to?
Oh, okay. So hot takes on that. I was
Mm-hmm.
not prepared for this question. Hot take. It's hard not to think of Steppenwolf's Magic Carpet Ride.
Love it.
Um, that speaks to my also my Star Trek, uh, my Trekkie nature. It's hard not to think of some Zeppelin. Kashmir could be
Okay.
fun, or to really flip the script on it, something messed up but very connected to my Canadiana, um, like some Celine Dion or some Brian Williams, just because I know it would upset you to like it.
Thank
Um,
you. Thank you.
like some Summer of '69 or no Heaven by Brian Adams. Sorry, I think I said Brian Adams.
Got it.
I think
Love it.
I think that's the cross section I would go for. And
Okay.
I'm gonna sit on this as soon as we hang up. I'm gonna have better answers for you, and I'm gonna call you back, and we're gonna have to do another take.
Yeah, I'm just going to ignore them because these are the cool ones. I love it. They're right off the top of your head. And we're going to go rapid fire here, sort of. Favorite nonfiction space book?
Case for Mars by Bob Zubrin. Um, I was actually a high school dropout. Um, Bob Zubrin's book convinced me to go back to school and become an aerospace engineer because I wanted to make astronomy a field science.
Now,
Um,
see, yep, see, based on your previous answer, everybody probably thought you were older than you are, and now you just realized that you're younger.
yeah,
Um,
early 40s and loving every minute of it, except all of the things I'm not loving about it.
yeah, there you go. And Bob's my bro. So let me see. Favorite science fiction book?
Collapsium by Will McCarthy. Not a book a lot of people have heard of. It's got like a super science component to it. But I think The Collapsium, technically by Will McCarthy, it's an extremely fun exploration of super science, but it's got a lot of not quite dystopian, but really off the wall. Hey, how does humankind evolve as a species in a world where all men and women can be brothers and sisters? Resource ubiquity, but in a dystopian way, but in a dark humor, dystopian way, etc., etc. Will McCarthy's The Collapsing. It's like 30 years old, but it's still very good.
Favorite movie?
Favorite movie, period, or favorite sci-fi movie?
Sci-fi.
2001.
Okay, so well, the one over my shoulder here, which you know I worship. Um,
2001 is it's just the mwah.
yeah, and then well, since you mentioned it, nonfiction. Go ahead. What the heck?
Nonfiction book.
I mean, nonfiction, a non-science fiction movie.
Oh, non-science fiction movie. Either Godfather or Casablanca.
Cool, got it. Yeah, I want Rick's on the moon because everybody goes to Rick's.
Yeah,
Cafe Luna.
I differentiate between best movie and most rewatchable movie because they
Mm-hmm.
all look different. and I will declare that I think the best film I've ever seen is Godfather, but I think probably Godfather 2 actually. Most rewatchable film is probably Moneyball for me personally.
I love it.
With
I
the
love it.
expected answer, I showed up on your podcast wearing.
I know, dude. I know, and I know where some of these are going to go. And the just because I know you, um, and we have, you're the one who got me hooked on Star Trek metal models, which are up here above me. Which people,
Oh yeah, I haven't deployed mine in my new house yet. So
yeah, I understand. So the last one. So we did movies, we did music. Oh goodness, I forgot what the last one is. It doesn't really matter. Oh, television series.
um, favorite or what I think is the best television series, like most
Okay,
rewatchable or best.
okay, Mr. Engineer. Look,
Uh, yeah,
do you want me to call you back again? I mean, seriously. I ask you one question, you break it into two. Now, what do you got? What do you got?
uh,
Both.
best The Wire.
Okay,
Most rewatchable Star Trek: The Next Generation.
got it. Absolutely. Um, okay, and we're running out of time, but I want to get your statement here. There's some person sitting out there who hears this, one of the three listeners we have, who is sitting there. Okay, seven, we're growing the market share. But they're listening and they're hearing this and they're thinking, okay, how do I get involved? What do I do? I don't know how, I've told you probably my story with Mr. Roddenberry. If not, I'll remind you later. But what do I do? How do I get involved? What what can I do? I don't have the skills. I'm not Mr. Engineer like Grant. What would you say to them?
Okay, so I guess I would say that you don't have to start as an engineer to become one, and engineering is not the only way to contribute. In pretty much every discipline, there's an opportunity to contribute to the cause of people living and working in space. Rick and I both, I think, had the privilege of working with one of the best space lawyers out there. We've had the privilege of working with some of the best scientists out
Mm-hmm.
there. The engineers are the engineers. That's a category. But in the arts and sciences, there is the need for every discipline. And the way that I would say the best way to attack that opportunity is go to conferences and meet people. Um, you will network, you will find opportunities. The only way to figure out how you can contribute to this sort of stuff, if you think it's important, is to go out and meet people and talk to them. Um, Networking is the number one thing to which I would attribute any success I've had. I've just been fortunate enough to meet the right people and be in the right places at the right times, and things have usually had good bounces, sometimes bad, but the shots you don't take don't go in, yada yada yada. But yeah, surround yourself with passionate people and be open-minded to adventure. Chris Lewicki, my co-founder in Gravity Lab, I'm going to butcher this, but his expression is, if you get a collect call from adventure, accept the charges. So put yourself in a position where you meet people and you can get swept off your feet, and then go have some fun. And you never know how you're going to contribute. And some of the most unsung heroes, I think, yeah, in space or on the policy side, or are there on the communication side. They're
Mm-hmm.
helping to socialize people to what we're doing, helping make roads, legal roads that the engineers can take their tech down, et cetera, et cetera. Sorry, Rick, I'm rambling a little bit on that, but you can probably typifies it pretty well.
No, I love what you're saying. I'm not going to try and rephrase it, especially you quoting Lewicki. That's like engineer on engineer. It's too much for me. I'm a civilian.
Well,
Uh,
Chris Lewicki's not an engineer; he's a Renaissance man.
and so are you, my friend. And I am so glad that we got to share some of your Renaissance mind today. So, my friends, want to thank you for attending one more version of the Space Revolution. We've had Grant Bonin with us. Check out his Gravity Lab website. Grant doesn't know this yet, but he will be attending and speaking at every New Worlds conference that we have from here on, and which is the campfire around which the revolutionaries gather as we move out into the frontier. But whether you hear this before or after the impending New Worlds Conference, make sure you show up there, or any other local event that you can attend that has to do with space. It's really it's very very exactly on point for him. We've said that. We are out the airlock.